In this tutorial we'll look at section 10.2, which is on integration by recognition. Now most people would have seen integration by recognition in their study of maths methods, okay? But it's something that we also need to look at in our study of specialist maths. Okay, so the idea is if the derivative of f of x equals g of x, then the integral of g of x is equal to f of x plus c. Okay, so we can use this idea to differentiate a function that's similar to the integral we're trying to find, trying to solve, and integrate the result. Okay, and we usually need to modify a little bit and things like that. Okay, so basically we use this idea when what we're trying to integrate is too difficult. Okay, a couple of things to remember: that our derivative of our inverse sine of x on a is equal to 1 on the square root of a squared minus x squared for all of the modulus of x is less than a. The derivative of the inverse cos of x on a is equal to minus 1 on the square root of a squared minus x squared for all modulus of x is less than a. And the derivative of our inverse tan of x on a is equal to a on a squared plus x squared for all values of x. Okay, so this is definitely best demonstrated through a couple of worked examples. Okay, so we're going to look at worked example 1. We need to differentiate the square root of 25x squared plus 16 and hence find the integral of x on the square root of 25x squared plus 16. Okay, so what we need to do, okay, is rewrite this. Okay, so we'll say, well, y equals 25x squared plus 16 to the power of a half. We need to find dy dx. Okay, we can use our chain rule. So we bring our half down the front, times by the derivative of what's inside our brackets here, which will be 50x, okay, times by our 25x squared plus 16 to the power of negative a half. Okay, well, half of 50 is 25, so we're going to get 25x over the square root of 25x squared plus 16. Okay, so we had a function, we've now differentiated it. Okay, what we're going to do now is integrate this function. So if we were to integrate 25x over the square root of 25x squared plus 16, right, with respect to x, we would get back to what we started with, which is square root of 25x squared plus 16. Okay, plus we'd also have our constant of integration, okay, which we don't really need to worry about too much in this. Okay, now you can see this function here that we're integrating to get this result is similar to this one but not quite the same. So what we need to do is take out our 25, okay, because it's a constant, so we can do that. As the integral of x over the square root of 25x squared plus 16 with respect to x still equals our square root of 25x squared plus 16. Okay, we can divide by our 25. Say, well, the integral of x over square root of 25x squared plus 16 dx is going to equal the square root of 25x squared plus 16 divided by 25 plus our integration constant of integration, sorry. And that's our answer, because look, we've integrated what we were trying to find in the first place. Okay, so we took the derivative of an appropriate function, integrated our result to get us back to our original function, modified our integral so it looked like what we needed, okay, and then rearranged. Okay, so we'll keep moving on. Now have a look at worked example 3 now. Okay, so we're going to differentiate x cos of 4x and hence find the integral of x sine of 4x dx. Okay, so what we need to use, because we've got two functions multiplied together, is our product rule. So we can say, well, f of x equals g of x times h of x. So what we need is our g of x. Well, we're saying that's our x. We need our h of x. That's our cos of 4x. Okay, so we need our g dash of x, which is 1. We need our h dash of x, which is minus 4 sine of 4x. Okay, we need to bring them together. So we get our 1 times cos, well that's our cos of 4x, minus our 4x sine of 4x, okay, as our integral. Okay, so if we, as our derivative, okay, so that's going to be equal to, that's our f dash of x. Okay, so if we integrate cos of 4x minus 4x sine of 4x, okay, with respect to x, okay, then we're going to get back to our x cos of 4x. Now what we can do is we can split this up and say, well, we've got the integral of cos of 4x dx minus 4 times the integral of x sine of 4x dx equals our x cos of 4x, which is what we, so this part here is what we actually want. Okay, so what we need to do is isolate this by itself. Okay, so we can take away this integral across. So we've got minus 4 outside of x sine of 4x, and that's going to equal our x cos of 4x minus our integral of cos of 4x dx. Okay, and we could divide by our negative 4 as well. So our integral of x sine of 4x dx equals our x cos of 4x on 4 plus our integral of cos of 4x dx on 4. Now we can't just leave our integral of cos of 4x like that. That's not a really good way to do it. Okay, and say that we've got x cos of 4x on 4. Okay, well when we integrate our cos of 4x, we get 1 on 4 sine of 4x, but we're also dividing it by 4. Okay, so we're going to get our plus our sine of 4x over 16 instead. Okay, and all we need to do now is, sorry, I forgot my negative on this one. Okay, so we can say, we're netting this up a little bit if we like, okay, and say that we've got negative 4x cos of 4x plus sine of 4x all over 16 plus our c, okay, and we are finished. Okay, because we isolated what we were trying to find, okay, and just rearranged to get what we needed. Okay, we've got one more worked example to go. Okay, so we're trying to find the derivative of x times the inverse cos of 2x, okay, and hence find the integral of inverse cos of 2x with respect to x. So again, we've got a product rule question. So I'm saying we've got f of x equals g of x times h of x. Okay, well we're going to say our g of x is equal to x. Our inverse cos, our h of x will be our inverse cos of 2x. So mistake there, so g dash of x then is equal to 1. Okay, our h dash of x, okay, is equal to our minus 2 over square root of 1 minus 4x squared. Okay, so we bring everything together, okay, which means we've got f dash of x is going to equal, well, we can say we've got our inverse cos of x, okay, minus 2x on square root of 1 minus 4x squared. Right, so what we need to do is we need to integrate this. Okay, our integral of our inverse cos of 2x minus 2x over the square root of 1 minus 4x squared dx. Okay, and we know that's going to equal what we started with, which was x times the inverse cos of 2x. Okay, you can see this is the part that we wanted. Okay, anyway, okay, and so we could split this up and really say that we're going to take away our integral. Okay, split it up there and say that we're going to the integral of this part minus the integral of that part, so we can add it across and say, well, our integral of the inverse cos of 2x dx equals x times the inverse cos of 2x plus the integral of 2x over square root of 1 minus 4x squared dx. Okay, so we're getting there now. Okay, we're getting to something that we want. Okay, so if we're just looking at this part now, okay, well, what we need to do, okay, is, okay, it's a little bit tricky because we've got to do a substitution for this one. So what we're going to do is let so u equal 1 minus 4x squared. So that means our du dx, okay, will equal negative 8x, okay, which means dx on du equals 1 on minus 8x, okay, which means our dx equals our 1 on negative 8x du, okay, which means then, we're looking at our integral, we can say, well, we've got the integral of 2x u to the negative a half, okay, times by 1 on negative 8x du. So integral then, well, our 2 and our 8 can cancel out to be 1 on 4, negative 1 on 4, so I'm going to bring that out the front. Okay. And our x also cancels out, so then we're left with our u to the negative a half du. Okay, which means that bit's going to equal negative a half u to a half plus c. Okay. So that means we can say that that bit is negative a half times the square root of our u, but we knew what our u was, that is our 1 minus 4x squared. Okay, so we can put all this, so this is what this part equals, so we can build it up for our answer here. So I'm going to write it over here, separate it a bit. So I'm going to say then our integral of our inverse cos of our 2x dx, which is what we're trying to find, okay, is equal to x times the inverse cos of 2x minus a half times the square root of 1 minus 4x squared plus c. Okay, so again, still doing the same process of finding our derivative and then integrating it. Okay, so you can see this is probably as tricky as they can make it. Okay, so we're having to use our product rule to find our derivative in the first place. Okay, and then we're having to use one of our more advanced integration techniques to integrate part of that derivative. Okay, but look, you've been doing a lot of work like this in the past in some methods. Okay, you've also been doing derivatives before, doing integrals before, so it's really just bringing a lot of ideas together into the one section. So you shouldn't hopefully have too many dramas with these questions.